units are really heavy algebra topics. You'll work with them again next year when you're in Algebra 1. But Unit C is the one we're currently on, solving equations. Then Unit D is linear relationships. We'll work on that November and December. And then functions in December and January. It says after Unit C, D, and E, there will be a final exam. Now, not a final exam that it comes for 20% of your grade, like in Algebra 1 or students that are in geometry or next year when you're at the high school. Each class you take next year at the high school, you take a final exam at the end of the semester. This one is not counting for 20% of your grade, but it's going to be covering the 3 units that we have here. So it's going to be on Unit C, Unit D, and Unit E. It'll be close to around the end of semester 1. It might be a little past it. So the semester might end and it might be a few weeks later or it might be close to that time. It is still going to count just as a test grade. But you won't be able to retake this exam. And the key thing is I don't want you to throw out any of these notebooks or workbooks for C, D, and E. So where A and B units, sometimes when you get B back, you can put it in the recycling. We're not coming back to it really this year. It will be part of that assessment. But Unit C, D, and E you want to keep because you will have a final exam on these. So what we want to look at right now is Unit C2. And we're looking at solving equations. And again, if you were solving this one, the first thing it says is identify the operation and identify the inverse. So the operation in this problem is subtraction. The inverse of subtraction is to add, and we're going to add 3. Now, some of you were confused when you said negative 12 plus 3. Negative 12 plus 3, those are opposite signs, so you are actually subtracting. And if you look at the number line over on the wall, and you think of where negative 12 is up here on that number line, and you are adding 3, you should be moving to the right. And so if we had that, we would have negative 9, right? The sign stays with the larger one and you subtract. And so G just equals negative 9. And we're done with the problem, right? One step. So some of the ones today are that simple in your homework. Now, if you get this answer, G equals negative 9, the question is, how do you make sure you got the right answer? So I'm going to be asking you to do a check. When you do a check, what you're going to be doing is writing the original problem. So you'll write the original, and you'll substitute the variable. And instead of the variable, you'll put what it was equal to. Substitute what the variable was equal to. So, if I look at this equation, and I'm going to write down here the word check. So please, in your workbook right below this, write check. This is what I would see. Instead of writing G, what was my G equal to? G equal negative 9. So we put negative 9 minus 3. And then we put these question marks because we don't know yet if it is equal to negative 12. And for some of you, you might want to think of this as negative 9 and subtraction as plus a negative 3, but is that equal to negative 12? So negative 12 equals negative 12, and it checks. The answer was G equals negative 9. Okay? That's what my check might look like. The next problem in your notes that you saw, what's this one? 3n plus 2. Was this in the video that I had? It was, yeah. So we're going to subtract 2 from both sides. And we ended up with 3n was equal to negative 7. And we are inverse operation of multiplying by 3 is to divide by 3. Now I will see some really interesting ways that some of you write that. I will see this, negative 7 with the 3 out here. I don't want you to do that. I will see a divide sign like this instead of this. People will put divide 3. As long as you kind of keep it in the right order, but I am really going to try and get you to use just this line for division. And on this side, 3n divided by 3n, that gives me this 1n. And on this side, we leave it as negative 7/3. And we're done with the problem. Someone said, can I change it to a decimal or to a mixed number? Why? it's negative 7/3. And if we check this, if I go to do the check, I'm going to take 3 times negative 7/3 plus 2, and the question is, does it equal 5? Negative 5. And if I multiply this, I get negative 21 over 3, which is negative 7, plus 2. That checks. It is negative 5. Okay? So that's how I can do the check. Now, in the last class, I had someone looking at this problem, and this is what they did first. They said, first step, Mrs. Thompson, we're adding 5. And they gave me this answer. They said 12 is equal to k over 2. And it's a simple mistake, right? What? And it's not negative 12 either, right? But here's what happens when you do these checks, right? So at this point, if you thought you did the problem right, your next step would be to multiply on both sides by 2, because this is division by 2. And if you divided this by 2, this is the wrong answer, by the way, right? You'd get 24 equals k, because the side would still be 1k. This is wrong, right? There was a mistake in here. But if you get this answer, some of you are just like, yeah, there's a 24 on the worksheet, or yeah, that checks, and you don't actually do the check. So this is where this check comes in really handy. Because if I ask you to check this, and you put negative 7, the original problem, right? And the question is it equal? And then you put k, which is 24, divided by 2 minus 5. 24 divided by 2 is 12. And 12 minus 5 is 7. And some of you will just say, yeah, it checks. Does that check? Is negative 7 ever equal to 7? No, that is not a check for this. So then you go back and go, okay, yeah, I did this, right? 24 divided by 2 is 12. Okay, so then you go back and you want to work through the back part of the problem. So some of you are working on other stuff. Please pay attention so I don't have to go through this again. So you go, yep, this was right. This was the mistake, right? What should this have been when I take negative 7 plus 5? It should have been negative 2. And if I would have gotten a negative 2, then that would have changed this answer to negative 4. And then I go over here and I go, oh, well, if this is, do I have to erase all the work I've done? No. So some of you will make a mistake and you'll erase everything. And you'll still not find your mistake. Then you'll erase everything again, and then I can't tell what you even did. But I didn't have to erase that, and I can write in what I now said k was equal to. And this comes out to be a negative 2. And does that work then to give me negative 7? That does work. So the answer was k was equal to negative 4. But it is so easy to make little mistakes along the way that some of you don't even realize you've made the mistakes, and then you erase everything, and you never really do these checks, okay? The question with the checks is, do we have to do every single check? No, but this is wouldn't even be hard to plug in your calculator, right? Negative 4 divided by 2 is negative 2 minus 5, and just do that mental check or on your calculator. So we have these algebra tiles that I gave you. And if you haven't taken out, I would like you to take out the rectangular ones right now. And on those rectangular ones, I know that these are green, and that has a plus on it, and the back side is red, and it has a minus. So this is what your algebra tiles look like. So it says sometimes equations can take many steps. One way to make this process easier is to visualize it. So this is visually doing. We're not going to use those large ones, but do you see how they are saying that this is the visual representation of x plus 3 equals 5? This is the x, this is 3 1s equals 5 1s. Does that make sense to everyone? So take, if you need to dump the whole bag out, take all the big rectangles out and all of the little tiny squares, and then put the big ones back. So if I was representing this visually, what I would then do was I'd say, okay, this shows x plus 3 equals 5, and I would remove these 3 1s from both sides. If I remove 3 from one side, I have to remove them from the other. And this would leave me a very simple answer. We could do this without these algebraic tiles, right? Of this 1x equaling 2, 1. So x equals 2, okay? So that's what we're going to kind of try and show as we do these. And I want you to try and put this model between you and your shoulder partner on the desk. This is telling me how many x's? 2 x's. Then I have 4 what? 1s. These are going to be the 1s. Then I have 3 x's and 9. So between the two of you, please do this on your desk. So if I, and this was originally that you are writing down. This was the 2x. This was the 4. This was 3x. This was the 9. So this exact equation, this is the model of it. They said they regrouped them. How many x's can we see all together now? 5. Now we saw 5 x's before. It's just that they were kind of spread out, right? So this is the adding like terms. On the worksheet that was due today, C1, that was what you did when you added 2x plus 3x. You were adding like terms. So we had 5x plus 4, please write that, equals 9. It says now take away 4 1s on each side in your notes. So if I take these 4 away, right, and I take away 4 on this side, right, I am left with 5 1s and 5x, which means each x is equal to 1. So each x was equal to 1. Okay? Now, some of you might be saying, I don't need to visualize this, Mrs. Thompson, this is stupid, I can do it all in my head, I can show the operations on my paper. That's great. But for some people, this will just help to make sense of it. So, we're going to model these two together. We're going to do them on this sheet. You do not have to do them on the space up here. That's where I'm going to show them. But what I do want you to do is show me x. We're going to do these two equations down here. So we're going to do this equation first, and then we're going to do this equation second. So right now you want to model it, which means I want to put that x. Then how many 1s do I need to put? 3. 3 1s, right? Then I need to put how many more x's? 2 more x's, right? So does this make sense of how we can model it? X plus 3 plus 2x. And then what do I need on this side? 9 1s. So please, between you and your shoulder partner, I need to just be able to see this model. Okay? And if you've done this, then regroup it, right? Now regroup it by putting all of your x's together. And if I put all these x's together, I now have what equation? Could we rewrite this right below here as 3x plus 3 equals 9? Yeah. And then, if I do something on one side of the equation, if I remove 3, right, what do I have to do on the other side of the equation? I have to remove 3. Now, I just want you to take a look as I'm looking at this. Across from each x, I have how many 1s? 2. Which, if we were looking at our equation, right, don't you agree that this would have been when I removed 3, 3x equals 6, and you would have divided by 3 and said x is 2. I would like you right now to model this equation, right? So 4x plus 1 plus the 2x is equal to the 7. I'm going to come around and check yours, that you have it set up first. So I heard a few of you, when you rearranged this, so you had your 6 x's, right? So I saw you regroup those and have 6x plus 1 equals 7. And then I saw the removal of 1 from both sides, right? And so 6x's equals 6, and x, Evan, you had a solution of
1.
1, okay? because 6x was equal to 6, which means each x had to equal 1, okay? Now, we're going to do one more, or I'm going to show you one more with this, with the distributive property. So today's homework is pretty easy. It's a one-step equation. It's still not even two-step, but then we get in, like tomorrow, to like distributive property and adding like terms and all of it. So I just want you to write below this one. Do you see that this is a group of x plus 1, another x plus 1, x plus 1? And the original problem said that there are 3 of them. So 3 times x plus 1, right? So there are 3 groups of x plus 1. That's what this group is an x plus 1 group. There are 3 of them, and that was equal to 9. And when we rearrange it, this is what you do when you're eliminating that parenthesis with the distributive property. You are regrouping your x's, which leaves us with 3x when we use the distributive property, plus 3 equals 9. And then what did they do next? If you're reading over here, they take away 3 1. So they take away 3 on this side, remove them, and you take away 3 on this side and remove them. And when you remove those from both sides, you are left with 3x is 6, which means each x was equal to 2 1. Now, some of you, this visualizing it and doing it in front of you, don't stack those, please, because then they fall and they go on the floor and go all over. Is that this visualizing is really going to help you. Some of you are like, this Thompson, I don't need that. We're doing it as part of this helps some people learn this better. What I want you to do is we are going to only do, we're going to do just this second one. Okay? So, if I am looking at yours and your partner's on your desks, I need to see how many x plus 1s. I need to have 4 of them. On this side, I need to have 5 1s, correct? And then I have to have a minus 3, and we haven't really done the minus 3, so please make sure you do that also. So please put the 5. I have to have an x plus 1, right? So if I'm looking at that, I have my x plus 1, that's one of them. Is this going to be another x plus 1? Can I line it up right below it? So please do this on your desk right now with your shoulder. Once you have this set up, what do I know if I add these two together? A positive and a negative 1. That's 0. And I add these two together, that's also 0. And I add these two together, and that's 0. So what is my new equation? My new equation is 4x plus what? Only 1, right? Equal 5. Because before we had 4x plus 4, but with this minus 3. Notice the 4 is not times negative 3, right? So the most common mistake that I'll have students make when we're working with distributive property as we get into some tougher problems is that they think they take 4 times everything. You don't. You just take it times what's in your parentheses. And at this point, we would remove 1 from both sides. So if we remove 1 from both sides, right, if I remove that, I now have 4x's equals 4. And x again here was equal to 1. Okay? We're not going to do the other one. What I do want you to do is to turn in your workbook to page 42. And I believe it's 42 and 43 is where the assignment is. 42 and 43. Inverse operation. You need to show multiplying by 3 over 1. And say, well, I just do it in my head. Well, that's great. I can't see into your head. So put it on your paper. And yes, by the way, you can start putting all those back in the baby. That would be great. So when I look at this answer, I am looking at negative 11 times 3, which gives me negative 33. Now, here is this letter R, this letter P, where people start making mistakes. If I look at letter P, if I look at letter L, what is the operation in the problem? the operation in both L and P is division. Inverse of division is to multiply. But this negative, that kind of messes with us. So what I want you to do is move the negative to the denominator with the number and make that a plus u. If this is a minus a, you're going to make it, you want to do this now on your paper. You want to change the negative to a plus and put the negative with the 13. So, in letter L, what we are saying is that 14 is equal to u divided by negative 4. The opposite of dividing by negative 4 would be to multiply both sides by negative 4. So that's like negative 4 over 1. So that on this side, negative 4 over negative 4 cancels. And on this side, yes, you may use your calculator, but negative 4 times 14 so that u equals, okay? Minus a negative. Last year you guys worked with integers. So you should be able to do most of this worksheet without your calculator because I do want you to show. But if you need to use your calculator to multiply some of the numbers or to check them, you could. If you don't know 14 times negative 4 and you want to multiply that out. But this worksheet is actually easier than that test of knowledge that had 2 steps on it. You want to make sure you have everything today done through this worksheet and the